Question number 13 and 14 are very similar. So on number for both of these, we're asked to determine whether the statement is true or false. Now for number 13, we're asked if Ted is a subset of the set Bob, Carol, Ted, and Alice. This is going to be false. And then number 14, we're asked if the set containing Ted is a subset of Bob, Carol, Ted, and Alice. And this one is true. So again, what's the difference between these two? If you notice here, Ted, this is just an element. That's not a set. So if you're talking about subsets, you have to be comparing sets to other sets. So if I were to ask you, down here, is the set of Ted a subset, then it makes sense. So it might be true or false. I can really look at it. But this one up here, as soon as I see Ted, Ted is just an element, it's going to be false. Now what I could do to make this true is if I could go ahead and say that Ted is an element of the set containing, Bob, Carol, Ted, and Alice. So this first one is going to be false because Ted is not a set, and we shouldn't be talking about it being a subset of anything else. It's just an element. And then on number 14, it's true because, it is a set, the right-hand side is a set, and it happens to be contained within it. Okay. A similar one, a small variation on this, if I were to go ahead and ask you, is the set containing Ted an element of the set containing Bob, Carol, Ted, and Alice? You would say false, because this is a set, and a set is not an element of this set. Okay. Number 15 and 16, the directions are to ask us whether we can put in a subset, not a subset, proper subset, or both proper subset and subset to make this a true statement. So remember the difference between, a subset and a proper subset. This one's subset, and then proper subset. What's the difference between these two? Okay. Well, a proper subset says, okay, it's going to be a subset of it, but it is not equal to the other set. So looking at this one right here, number 15, the first thing I need to do is decide if it's a subset. And then my second question is whether or not it's proper. So the sets containing elements A and B is a subset because A and B are also on the right-hand side. So it's definitely a subset. Now my second question is it a proper subset? And then the answer is yes, because the set on the left, AB, does not equal the set on the right. There's a lot more elements in there. So it is also a proper subset. So we can put in both. For number 16, is it a subset? We said yes, because every element on the left-hand side is also an element on the right-hand side. So it is a subset. And then the other question is it a proper subset? And the answer is no, because the two sets are equal to each other. So the only symbol I can use in this example is subset. Let me go ahead and add on one more. Suppose I have the set 6, 7, 8. And on the other side, I have 6, 7, 7, 6, 8, 7, 6, 6. Same question. Which symbols can I use? Can I use subset, proper subset, both, or neither? Well, the set on the left, 6, 7, 8, is definitely a subset because you can see that all of those elements are contained in the right-hand side. My second question is, are the two sets equal to each other? Yes, they are. Because this set on the right, remember with sets, the order of the elements does not matter. The set A, B, C is equal to the set, B, C, A. They're equivalent. And then also if you repeat items, that doesn't change the set either. So since these two sets are equal to each other, then they are not proper. Oops, not proper. Not proper subset. So the only symbol I could use in this case would be subset. Number 18, list all possible subsets of size 3 for the given set A, B, C, D. Okay, so first let me just talk a little bit about how many subsets are there all together. Well, we said, let's see, the cardinality, there are 4 elements in the set, so they're going to be 2 to the 4 or 16 total subsets. That's a total number of subsets. I don't want to list out all of them. I will at the end of this, but for right now, for this question, I just want to list out the elements that have size 3. When you're listing them, you want to have a nice systematic way about approaching them so that you don't, miss any. But also remember that we don't count repeats, and we don't want to go ahead and, if we change the order of elements, it's still the same set. So I'm just going to start out in the order they're given. So I'm going to start with A, B, and C. There's a subset of size 3. And all of these are going to have the curly brackets. Then I can say, okay, let me take A with B and D. Okay, so there's starting with A and B, I took A and B with C, and then A and B with D. So that's done. And I said, all right, how about I go ahead and try A and C together? So if I have A and C, I don't want to, I don't want to match it with B. I've already got A, B, C, but I do want to match it with D. So I can take A, C, and D. There's another subset. And then if I match A with D, I got nothing more there because I've already included the B and the C. So I said, all right, how about I go ahead and start with the next letter? So what about BC? If I start with BC, I can do BC, D. And then there's no other possibilities. And I'm like, okay, so now I'm done with that. I can't start with C or D because if I go with C and D, I've already combined them with A over here and B over there. So we're done. So I have 4 subsets that are of size 3. Okay, so that's what they asked for, so we're done with that one. Just because we're talking about subsets, like I said, the number of subsets we know is going to be 16, 2 to the 4. The number of proper subsets, how many will we have there? Well, that's going to be 2 to the 4 minus 1. So it's going to be 16 minus 1, or we get 15. That'd be the number of proper subsets. What if I had asked you to list all subsets? So there are 16 subsets I have to list. Again, you want to go about it in a systematic way. Now we have subsets of size 0. So over here, I'm going to put the size. So size 0 could have 1 element, 2 elements, 3 elements, or 4 elements. So let's go ahead and list those out. There's only one subset that has no elements in it, and that is the empty set. And it's a subset of every set out there. How many subsets do I have of size 1? Well, I've got 4 elements. So I'm going to have 1, 2, 3, and 4. The set containing just A, just B, just C, just D. 2, I said, all right, how many with 2? So that's when I got to be a little bit careful about how I list them. So again, I'm going to take A with B, C, and D. Then I'll take B. I won't mix B with A because it's already been combined up here, but then with C and D. Then I start off with C. Who can I mix C with? I've already got it with A, I've already got a B. Oh, I can mix it with D. So those are going to be my sets. So I'm going to have AB. I will have AC. And then AD. I will have BC. Come down here. I will have BD. And then lastly, we will have CD. So there happens to be 6 of those. Okay. How many of size 3? Well, we already listed those 4 over here. I'm not going to go ahead and relist them, but we got those 4. 1, 2, 3, 4. And then how many subsets of size 4? There's just one of those, and it's equal to the original set. So A, B, C, and D. Okay, so if you needed to list all of them, this is how you would do it. Find the number of subsets, 2 to the n, in this case 16. Number of proper subsets is going to be 2 to the n minus 1. So in this case, 15. And again, when you're listing elements, find a nice systematic way to approach it. Number 32, we're asked to use the Venn diagram to list the elements in the set in the roster form. So the roster form says, just list them out. Okay, I'm going to do a couple variations on this one. First, let's go ahead and look at this particular set. We want to find A intersect B complement. Okay, so if I were to look at A intersect B, that would be this piece right here. So what is everything not in A intersect B? So if I were to go ahead and say, okay, I don't want these, what am I left with? I've got 11, 14, and I've got 12, 15, 16, but I've also got 18 and 19. You want to include everything in the universe except those elements that are in the intersection. Okay, let's look at another similar example of this. So let me go ahead, again, I'm going to do a different variation of this. Let's go ahead and say I want to find A intersected with B complement. So I said, all right, so what's in A and then not in B? So not in B, let me do that in orange. So here's B, so what's not in B is going to be all this stuff out here. So which elements are in A and not in B? Just these two. So that's going to equal the set containing the elements 11 and 14 only. If you prefer, you could go ahead and write these out. So like say the set A is equal to 11, 14, 13, 17. And we're going to intersect that with not B. So B contains 13, 17, 12, 15, 16. So I have to take the complement of that first. So the complement of B is going to contain 11. So it's all the things not in here. So I have 11, 14, 18, and 19. And then I can intersect that with a set A. It's 13 and 17. So which ones do these have in common? 11's in both, 14 in both, and that's all. So again, we get the same answer, the set containing 11 and 14. Okay, let's go ahead and do one more variation on this question. Again, I'm going to go ahead and use the same picture, but we want to find A union B. So that means I'm going to include everything in A. Also, anything that is in the set B, or in the set B. So all of that has to be covered. That's going to be my answer. So I have 11, 14, 13, 17. I also have 12, 15, and 16. We would not list the intersection twice. So there's all my elements in A or B. Use the accompanying Venn diagram that shows the number of elements in regions 1 through 4 to answer the question. Okay, I want to point out that right here we are told that the Venn diagram is showing the number of elements in each region. So it's giving me the cardinality. Okay, so when I see this number 17 over here, that doesn't mean 17 is an element of the set A. It's telling me that the number of elements in this portion, not in all of A, but in that piece, is going to be equal to 17. So let's go ahead and look at this one here. We want to know how many elements belong to the set A. Well, the set A is right here, and it's made up of these two regions. And so it contains all of these and all of these. So it's going to be equal to 17 plus 7. So it'll have 24 elements. 24 elements in the set A. Let me go ahead and, again, I'll do some variations on this one. Suppose I want to know how many elements are in the set B. So the number of elements in the set B. So again, now I'm going to go up here and I'm going to look for the set B. I'll go to my set B and notice that I have these two regions. So it's going to be 7 plus 16 or 23 elements. Let's look at the number of elements in the union, A union B. Okay, so again, coming up here, let me go ahead, I'm just going to color them in. So A is going to be anything in here, B, anything in here. So the union is contain everything inside of here. So I've got all three of these. So 17 plus 7 plus 16, and that's going to give me 40. So there's 40 elements in the union. And then the last one, let's go ahead and look at the intersection. So how many elements are in the intersection of A and B? And A intersect B is just right here. We have only one region with 7 elements in it. Oh, you know what? I am going to do one more. Last one here. Okay, let's go ahead and look at the number of elements that are not in A or B. Or not in A and B. Sorry, not in A and B. Okay, so A intersect B is this part right here that we have in red. So I don't want that. I'm going to count everything else. So the 17, the 16, and then don't forget I have the 81 out here. So we get the 17, the 16, and then the 81. And so that's going to be 114. Okay, so like I said, there's a couple examples using a Venn diagram to find the cardinality of a given set. Number 49, we've got a survey problem here. So it says Monticello's residents were surveyed concerning their preferences for candidates Moore and Allen in an upcoming election. Of the 800 respondents, 300 supported neither Moore nor Allen, 100 supported both Moore and Allen, and 250 support only Moore. How many residents support only Allen? So before we try to answer this question, we're going to use a Venn diagram to help us represent the information. So I've got a set for Moore and I have a set for Allen. And here's my set of people surveyed. Okay, so I've got to fill in, I might not have to fill in all 4 regions, but my goal, I'm thinking, is to fill in these regions. Okay, so what information do I know? I'm given that, there were 800 respondents total to the survey. So the number of elements in the universe is going to have to equal 800. So all 4 regions combined have to total 800. I know that 300 support neither Moore nor Allen. So not Moore or Allen, so the 300 go out here. If you wanted to represent that with, set notation, the number of elements in A union B, not. So not A or B. Or in this case, I should use Moore and Allen. Let me go ahead and change that to Moore and Allen. So neither Moore or Allen. Okay, so that has to be 300. 100 support both Moore and Allen. So both Moore and Allen is going to be right here in the intersection. And that has to be 100. And again, so the number of elements in Moore and Allen is going to be 100. And then the last piece of information that we're given is that 250 support Moore only. So the 250 has to go right here. I don't want to put it in here because that's also part of Allen. So it's going to go here only. Okay, so that's all the, so let me, so this would be the number of elements in Moore and not in Allen. That's 250. Okay, so that's all the information I'm given. Let's see if I can answer the question. My question was, how many residents support only Allen? So only Allen is going to be this region right here. Okay, so right now I don't know, but I can figure it out. I know that the total has to be 800. So 800 minus the other 3 regions. So 250 plus 100 plus 300. So I have 800 minus 650, so that's going to be 150. So 150 supported only Allen. At Eaststone University, there are 869 students taking college algebra or calculus. 502 are taking college algebra, 422 are taking calculus, and 55 are taking both college algebra and calculus. How many are taking algebra but not calculus? Okay, so I'm going to go ahead and use a Venn diagram to represent this information. Oops. So I have a set here for, we'll call this algebra, and then we have another set of students who are taking calculus. And then we have a set of all the students. Okay, so what information do we know? Let's start with that. So we know that 869 students are taking college algebra or calculus. So those taking college algebra or calculus is going to have to total 869. I can't put that in there right now because I know it's going to be these three all together. I don't know where they fall, so I'm going to have to, start more towards the middle. What other information am I given? I know that there are, here we go, 502 are taking college algebra. So the number of those taking college algebra is 502. So college algebra is going to be here and here. Again, I don't know how to split those up, so I can't do that one yet. And let's see, we also got that 422 are taking calculus. So again, calculus is going to be here and here. That's going to have to total 422. And then lastly, I am given that 55 are taking both. Okay, so the number of those taking algebra and algebra and calculus are, that's going to be 55. So 55 goes in the middle. Perfect. Now I can work my way out. Okay, so now that I know that I have 55 here in the middle, I can figure out how many took calculus. So remember, for calculus, there's a total of 422, but there were 55 in the middle. So that's going to go ahead and leave me with 367. So 367 go here. And then how about those taking just algebra? So for just algebra, I knew that we had 502, but take away the 55 that are taking both algebra and calculus, and so that's going to leave me with 447. So 447 go in here. Okay, now I can answer the question. So coming back up here, what was the big question? How many students are taking algebra but not calculus? So algebra but not calculus. That's going to give me 447 students. And again, there's a number of different questions I could ask you once the survey is done, but we're going to leave this one right here. Okay, now we have a survey problem. In a survey of 280 people, a travel company asked people about places they plan to visit in the next 5 years. The results were as follows. 48 plan to visit Europe, 58 plan to visit Latin America, 34 plan to visit Asia, 14 plan to visit Europe and Latin America, 12 plan to visit Latin America and Asia, 11 plan to visit Europe and Asia, and 4 plan to visit all three. How many people plan to visit exactly 2 of these places? Okay, so first what I'm going to do is draw a Venn diagram that represents, all these people in the survey, and then I'll be able to answer the question. This first part is going to be the same regardless of what question I asked you. I get asked like 10 different questions on the survey. So first I got to figure out, how to draw my Venn diagram. How many sets should it contain? Well, I've got Europe, Latin America, and Asia. So I'm going to need to have 3 sets. So one for Europe, one for Latin America, and another one for Asia. So I'm going to label these E for Europe, L for Latin America, and A for Asia. And so now I'm going to go ahead and start filling in my Venn diagram with the cardinality of each set. So how many numbers, how many people are in each region? Usually when you're filling in surveys, there are some that are a little bit different, but you try to look on the inside out. Like I know there's 48 people who visit Europe, but I don't know where they're going to go. There's 4 different regions I can put them in Europe, so I can't really start there, and I don't know how to break them up. So try to find the smallest or most restrained set that you can. So I'm going to go ahead and start here with, I have 4 plan to visit all 3. So 4 plan to visit all 3. So where do all 3 of these sets intersect? 4 people go in there. Okay. So now I'm going to start moving outward. So now I know 11 people visit Europe and Asia. So Europe and Asia is this piece right here, and that has a total of 11. I've already got 4 of them counted for, so 11 minus 4, 7 are going to go in this region right here. So now I have a total of 11 in Europe and Asia. 12 plan to visit Latin America and Asia. So Latin America and Asia, this is where these 2 overlap, and I have to have 12 people in there. Again, I've already counted these 4, so 8 more go in here. So that's 12 minus 4 is 8. And now I'll look at these 14. So 14 plan to visit both Europe and Latin America. So Europe and Latin America, this part, so it's inside Latin America, it's inside Europe. So this part right here has a total of 14. I've already counted 4 of them, so the other 10 must go right here.
For this particular problem, I could stop right here because I have enough information to answer the question. The question is how many people plan to visit exactly 2 of these places, so I could do that right now. It's going to be these 10 because they visit both Europe and Latin America, but not Asia. These 8 should be included because they visit both Latin America and Asia, but not Europe. And then these 7 because they visit Europe and Asia, but not Latin America. So I'd have 10 plus 8 plus 7, 25 people plan to visit exactly 2 of these places. So like I said, if I'm looking ahead and I just have one question, I could stop right here. I'm going to continue because I think this is just a good problem to work all the way out. Because like I said, I could ask you a lot of different questions on this survey. How many would plan to visit exactly 1? How many plan to visit, only Europe? How many plan to visit none of these? So there's a lot of other questions. So I'm going to go ahead and continue with this problem. I'm going to fill in all the regions. Okay, so I'm going to back it up a step. Pretend like we didn't, just do that number. And then let's keep going. So I know that I have 34 people. 34 people who plan to visit Asia. So inside Asia, the whole circle has to total 34. So what's going to go in here is going to be 34 minus what I already have. So the 7 plus the 4 plus the 8. So I've already got 19 accounted for. So 34 minus 19, I got 15 in here. 58 plan to visit Latin America. So again, inside here has to total 58. So if I do 58 minus the 10, the 4, and the 8, I get 36. So 36 goes in here. And now same thing for Europe. Those who plan to visit Europe was 48. So if I take 48 minus the 10, the 4, and the 7, and I end up with 27. Okay, so now I've filled in most of it. I haven't filled in everything. There's still one more region to fill in. How many people go out here? So this would be the number of people who do not plan to visit any of these 3 countries. Okay, so we have a total of 280 people surveyed. So 280 minus all of those I've already accounted for. So 27 plus 10 plus 36 plus 7 plus 4 plus 8 plus 15. So 280 minus 107. And so 173. So 173 plan to visit none of these. Okay, so now that I've got the completed Venn diagram, like I said, there's a lot more questions I can ask you. One example is, how many plan to visit none of these countries? That would be 173. How many plan to visit only Latin America? So only Latin America would be these 36. As they want to visit Latin America, but not Europe and not Asia. So like I said, there's a wider range of questions we can ask now. So please let me know if you have any questions. And actually, let me go back up to our solution. The original question was how many plan to visit exactly 2 of these places? And so like I said, we had these 10, 7, and 8. These wanted to visit Latin America and Europe. This was Europe and Asia, and then these 8 were for Latin America and Asia. All right, I hope this helps. And like I said, if you have any questions, let me know.